Hey there, pre-calc friends. As we continue on with section 4.2, we're going to keep looking at our unit circle here, and the reason why we are learning so much about the unit circle is because all of these angles that you see here, degrees and radians, are the most important angles that we need to study in trigonometry. What we need to do as our next goal is that every single angle you see here, we need to be able to do all 6 trig functions, sine, cosine, tan, and all the reciprocals, cosecant, cotangent, and secant. But there's a lot of angles here. Look at all these. So it's going to take a long time to do this. So why don't we do a little bit of a shortcut and just start with everything in the first quadrant. So in order to just focus on those angles, I think the best thing to do would just focus on these 2 important special right triangles that we've studied before in geometry. Our famous 30, 60, 90 triangle and the 45, 45, 90 isosceles right triangle. Now, if you remember the sides, what we're going to do is we're going to simplify the sides by drawing them with only numbers and not variables. And here's what I mean. The 30-degree angle is always the smallest angle in that triangle, so the smallest side, according to geometry, is the side opposite, which is this one. So we'll call that 1. We'll give that side a length of 1. The side opposite the 30 degrees will always be a length of 1. If you remember, in a 30, 60, 90, the hypotenuse is always double the short side, so that's always going to be 2. And then the leftover leg on the bottom here is always root 3 times the short leg, so this will just become root 3. So in that triangle, remember those 3 numbers, 1, 2, and root 3, where again 1 is the shorter side across from the 30, the 2 is the hypotenuse, and the root 3 is across from the 60-degree angle, or it's the longest leg. Okay, over here on the 45, 45 triangle, we're going to just call the leg opposite of the 45 1 to make it simple. And therefore, because it's isosceles, the other leg is also 1. And if you remember, the hypotenuse is always root 2 times a leg. So this will just be root 2 times 1. So in this triangle, folks, just remember 1, 1, and root 2. If you remember those 3 numbers for that triangle, then you will be golden. Because like I said, our goal is to eventually fill out this chart here for the 30-degree angle, the 45-degree angle, and the 60-degree angle, and all the other angles as well. But for today, we're just focusing on the first quadrant. Okay, so the best thing to do is to go back to our triangles here, and let's make a list. Let's take the 30-degree angle here. And let's do the sine of the 30 using our triangle and just basic SOHCAHTOA, cosine, and tan. And then all the reciprocals. Remember, the reciprocal of sine is cosecant. The reciprocal of cosine was secant. And the one for tan, of course, was cotangent. Okay, so let's go back to our triangle. And just remember, again, our friend SOHCAHTOA will always help us here. Okay, ready? We're starting with the 30-degree angle, so your eyes are all focused right here. And according to that, that means the opposite would be over here, hypotenuse would be here, and the adjacent would be here. Ready? Let's do it. Okay, according to this triangle, the sine, which is the opposite over the hypotenuse in this triangle, would be 1 over 2. The cosine, which would be the adjacent over the hypotenuse, would be root 3 over 2. And the tangent, which is opposite over adjacent, would be 1 over root 3, which remember we can't keep it in that form because there's a radical in the denominator, so we rationalize by multiplying by root 3 over root 3, of course. And that gives us root 3 on top. The 2 root 3's cancel and it gives you just a regular 3. And that's the tangent. Okay, great. Now to get the next 3, we just take the reciprocal of the ones we know. So cosecant, we're going to take the sine, which is 1 over 2, and flip it. And we get 2 over 1, or just 2. The secant is the flip of cosine. So if I flip cosine, I get 2 over root 3. But again, you have a radical in the denominator. If we clean it up, we'll eventually get 2 root 3 over 3. And the cotan. Now the cotan, if I flip the regular tan that I got here, I'm going to have to re-rationalize it. Can you see that? Because when I flip it, I'll get a radical in the denominator. But if I flip the original tan that I had over here, I won't have to do that. So as a shortcut, I'm going to flip the first tan. Here we go. That means I'll get root 3 over 1, which is just root 3. And those are all 6 trig functions for just the 30-degree angle. Now our goal is to do the other 2 angles in the first quadrant. So I'll make a little space here. And we can say for the 45-degree angle. And again, we'll do everything we did before. Let's take the sine of 45 degrees using our special right triangle, the cosine, and so on. And then we're going to move on and do the 60-degree angle, and we'll be all done. So if you feel like you want to do that on your own, just pause the video, do all the work, and we'll come back and check in together. All right, so I'm going to go back to my 45-degree angle, and again, just using SOHCAHTOA. The sine, and let's focus on, well, maybe we can pick this 45-degree angle. And remember, SOHCAHTOA. Sine would be opposite over hypotenuse, so 1 over root 2, which we clean up by multiplying by root 2 over root 2, which gives us that. The cosine, actually, if you see it back on the triangle, you'll get the exact same thing. And the tangent, which is just opposite over adjacent, would be the 1 over 1, or just 1. All right, let's flip everything. For cosecant, I'm going to flip the original over here, so I don't have to re-rationalize it. And I get root 2 over 1, or just root 2. Same thing for the cosine. Since cosine was really 1 over root 2, and I flip him. And then for cotan, when I flip 1, I just get 1 over 1, which is 1. All right, well, we should do everything else for the 60-degree angle. Same idea. All right, let's go back at our same triangle that we are on the left-hand side, but now I'm going to focus on this angle and do SOHCAHTOA based on that. Okay, I'm going to jump right to the answers since I'm sure you're getting this and you're doing a great job. So in a second, you're going to see all the answers pop up. Hold on. All right, there you go, folks. So everything for the 60-degree angle is there. Notice we had a couple things we had to re-rationalize again, and that's fine. But those are all 6 trigs for all 3 angles. And there you go. And now, because we know that, we can fill out this chart now. And beautiful. You see a little bit of symmetry going on. Can you see that? Can you see that sometimes when the sine is one value, the cosine is the other value? And when you flip down to the 60-degree angle, they flip. There's lots of flipping going on here. It's kind of interesting, the symmetry. One last thing we should do is just fill in the radians. So you remember 45 is pi over 4. That's how I remember the 4s. Which makes you think that 30 degrees should be pi over 3, but it flips. And 60 degrees should be pi over 6, but that flips. So to help you remember all of the radians with degrees. Well, there you go, folks. Our goal is to kind of memorize this chart or be able to do it pretty quickly with mental math. But if you're ever stuck, you can always use our special right triangles here. And plus, there's a really nifty hand trick, you've heard about it, that I'll teach next time on how you can memorize this entire chart by just using one hand. Great job, folks. You've learned all 6 trigs for the 3 big angles in the first quadrant. That's a lot of great work. Good job today, and I'll see you next time.